Many people believe that physics is one of the most difficult subjects out there. The principles are complicated and sometimes However, it's also one of the most interesting subjects to learn about. We learn about the origin of the universe and the laws that govern our world. There have been some incredible physicists throughout history who have made groundbreaking discoveries and changed the course of history. Ever wondered how we went from not knowing anything about the universe to being able to explore space? Here are the key moments in the history of physics that helped us understand our world. Ancient times before ancient Greece. Physics was intertwined with mythology. When the Greek philosophers started to question how nature worked, they laid the foundation for physics. They were the first to use reason rather than myths to explain natural phenomena. Thales of Miletus was among the first to attempt to explain the world using only natural causes. He lived between 624 and 546 BC. He was credited with predicting a solar eclipse, although this was likely an educated guess based on lunar cycles. But his student, Anaximander, took it a step further. Around 550 BC, he proposed that the Earth was a disk floating in a vast, never-ending void. He was also the first to suggest that the sun was not a god, but rather a rock or metal. After Anaximander was Anaximenes, who suggested that all matter originated from air. Other philosophers believed that the world was actually made up of water, but by around 400 BC, Leucippus and his student Democritus concluded that all matter was composed of small, indestructible particles. They called them atoms, because atomos means uncuttable in Greek. Throughout the Middle Ages, many Muslim scholars preserved and expanded upon Greek knowledge. In the 10th century, Al-Farabi described the motion of falling objects and the conservation of momentum, but physics really started to take off during the scientific revolution. This was a period of rapid scientific and technological advancement, began in the 16th century and lasted until the 18th century. Some historians argue that it started earlier with the rediscovery of ancient Greek texts. Either way, the scientific method replaced the reliance on ancient authorities and religious beliefs. Scientists began to experiment and test their hypotheses, and this led to many new discoveries. Heliocentric theory. One of the most important discoveries of the scientific revolution was the heliocentric theory, which states that the Earth and other planets revolve around the Sun. This was a radical idea, because it went against the long-held belief that the Earth was the center of the universe. It was actually the Polish astronomer Nicolaus Copernicus who published this theory in his book, De Revolutionibus Orbium Coelestium, in 1543. But it was built upon the work of several other astronomers, including Aristarchus of Samos, who had proposed a heliocentric model in the 3rd century BC. Unfortunately, Copernicus didn't have the tools to prove his theory. It wasn't until Galileo Galilei came along that we were able to observe the phases of Venus. Galileo also discovered from moons of Jupiter, which provided evidence for the heliocentric theory. As such, he was put on trial by the Catholic Church, because his theories contradicted the Bible. Despite the persecution he faced, Galileo continued to defend his views. His work paved the way for Isaac Newton's development of the law of universal gravitation. Newtonian physics. Isaac Newton was arguably the most influential physicist of all time. His contributions to science are so numerous that he has his own Wikipedia page listing them. Born in 1643, Newton developed the 3 laws of motion, which formed the basis of classical mechanics. His work on gravity also explained why planets orbit the Earth and why tides occur. Newton also invented calculus, which is a branch of mathematics that studies continuous change. He made significant contributions to optics, astronomy, and even alchemy. In 1704, he became the first Lucasian professor of mathematics at Cambridge University, a position he held until his death in 1727. Newton was knighted in 1705 and became Sir Isaac Newton. He died on March 31, 1727, and was buried in Westminster Abbey. The 19th century. During the 19th century, physicists began to explore the nature of light and electricity. In 1820, Danish physicist Hans Christian Ørsted discovered that a current carrying wire could deflect a compass needle. This discovery led to the development of electromagnetism by Michael Faraday and James Clerk Maxwell. Faraday also discovered the phenomenon of electromagnetic induction, which is the basis for electric generators and transformers. Another important development in the 19th century was the theory of special relativity, which was proposed by Albert Einstein in 1905. This theory revolutionized our understanding of space and time and showed that the two are intertwined in a 4-dimensional continuum. Einstein also developed the equivalence principle, which states that there is no difference between mass and energy. This is the basis for nuclear energy. Quantum physics. The beginning of the 20th century saw the rise of quantum physics. This is a branch of physics that studies the behavior of matter and energy at the atomic and subatomic level. Quantum physics is a strange and counterintuitive realm where the rules of classical physics do not apply. One of the pioneers of quantum physics was Max Planck, who in 1900 proposed that energy is quantum. This means that energy can only exist in discrete amounts or quantity. This discovery led to the development of quantum theory by Niels Bohr, who proposed a model of the atom in which electrons orbit the nucleus in quantized energy levels. Another important contribution to quantum physics was made by Werner Heisenberg, who in 1927 developed the uncertainty principle. This principle states that we cannot know both the position and momentum of a particle with perfect accuracy. The more accurately we know one, the less accurately we know the other. This is not a limitation of our measuring devices, but a fundamental property of nature. In 1935, Albert Einstein, Boris Podolsky, and Nathan Rosen published a paper that outlined a thought experiment that demonstrated the seemingly paradoxical nature of quantum entanglement. Their paper sparked a huge debate about the foundations of quantum mechanics, a debate that continues to this day. The question is, do we need a new theory to explain the behavior of matter at the atomic and subatomic level? Some physicists believe that we do, and are searching for a theory that would unify quantum mechanics with general relativity. Others, including Einstein, believe that quantum mechanics is a complete description of nature, and that we just need to find a way to make sense of it. Other important physicists. There are many other physicists who have made important contributions to our understanding of the world. Richard Feynman, for example, developed a new approach to quantum electrodynamics. His work led to the development of the first quantum computer. Feynman also made significant contributions to our understanding of particle physics. Another important physicist was Marie Curie, who was the first woman to win a Nobel Prize and the only person to win Nobel Prizes in 2 different scientific fields. She made pioneering research on radioactivity and the first studies of radium and polonium. Her work led to the development of new medical treatments for cancer. Wolfgang Pauli developed the exclusion principle, which states that two fermions may not occupy the same state. This principle is fundamental to our understanding of the structure of matter. Pauli also made significant contributions to our understanding of quantum mechanics and nuclear physics. What's next? Today, physicists are working on some of the most important problems facing humanity, such as developing new energy sources, understanding the origin of the universe, and searching for a theory of everything. With the help of powerful computers and new experimental techniques, physicists are making breakthroughs every year. Who knows what the future will hold? Perhaps one day, we will discover the secrets of the universe. We may travel to other dimensions or even other universes. The possibilities are truly endless. Which physicist do you think is the most fascinating? Let us know your thoughts. And don't forget to check out our other videos, which are designed to help you learn about the world around you.